students, how are you all? Welcome back to Ask IITians. Welcome back to the class of acid, bases, and salts. So, if you remember what we have read till now, it's just that we have find out that what are the acids, what are the bases, and then we have discussed what are the salts. Now we are going to discuss about some important part which you are going to find it out in your class 10th as well and into your higher classes as well. Okay, so and what the thing is, student, from this part you will be finding out it very interesting as well, because actually I like this concept very much. Now you'll say that, ma'am, you are solving so much of mystery that this chapter is good, this chapter is that, or this topic is like. So the topic is which we are going to study today is all about pH. Okay, so it's like we are going to see that how the pH affect, or what's the pH is, then the neutralization reaction, and then neutralization in everyday life. And these are the examples of the neutralization in everyday life. So how we are going to study all of these things, and how we are going to like understand the concept. So we'll see that. Okay, so first of all we are going to see the pH scale, then neutralization reaction, and then how's the neutralization reaction we see in our daily life. So that's how we are going to take our today's session, and this is the flow of our session. And within, like, after completion of all these topics, we will be completing this chapter. Okay, don't worry, these all are very simple things. So first of all, starting with the pH scale. So now student, you say, ma'am, what's the pH scale is? So pH scale is used to determine, as we have seen, that first of all, just try to remember the concept that what are the strong acids and strong base, and then we have seen that what are the weak acids and the weak base. Exactly. Now to differentiate like how they are stronger, or how any acid is weaker, to differentiate that strength of the acid and the bases, as on the basis of their strong acid and the strong base, or the weak acid or the weak base, we are having one concept, that is the pH scale. From the pH scale, student, you can easily identify, if you know the pH of that particular acid or a base, that what type of acid or a base is, whether it is stronger or whether it is weaker. Okay, so see, we know that we can we can learn their scientific definition. Then if someone asks you, you can just directly say that yes, pH is defined as the negative logarithm of the H ion. Exactly. But first of all, what's the use of the pH? We should know that, na? So pH, as we have already discussed, that acid and bases all are having their pH. So pH scale is used to determine the strength of the acid and base, and on basis of that we'll say that whether the acid or a base is stronger in nature or weaker in nature. And how we say that, we'll see that part. Okay, so don't worry about it. So first of all, student, if I tell you that the pH scale has been discovered by Sorensen. Okay, this is the name of the scientist who has discovered this pH scale. And now how we define the pH. So pH is defined as the negative logarithm of the H ion concentration. If you remember this thing, student, that for the acids, I have told you that they give the H ions in the solution, and the bases, they give the OH negative ion in the solution. So students, I have told you one thing more, that for the strong acid, there is the more number of H ions, more H ions will be there. And for the weak acid, the condition is that there is the less H ions. And if we talk about base, so the two condition will also be there, strong bases and weak bases. So the strong bases having the, oh sorry, strong bases having the more number of H ions, so it is having the more OH ions, and it is having the less OH ions. So see, that is the acids and that is the base. Okay, that we have find out that strong acid, strong base and weak base. Then we have seen one of the thing, that the pH is that which is defined as the negative logarithm of the H positive ion concentration. That means the concentration of the ion, that is the H ion, which we are getting in our solution, that is called as the pH, that is negative logarithm. See, this negative logarithm is the mathematical term. Okay, this is the mathematical term which we use in mathematics to solve the equations, or any of the sum like that, which depends upon the logarithm. So this is the very defined definition of the pH, that what is the pH is. Yes, it's correct that pH is used to determine whether the acid or a base is stronger or weaker in nature. That is why, student, pH depends upon the H ion concentration. Exactly, if there is more number of H ions, then it will be a stronger acid. And how it will affect the pH, we'll see that thing also, that whether the pH will be higher in that condition or pH will be lower in that condition. Okay, so it's just that what we have seen till now, that the pH is defined as the negative logarithm of the H ion concentration. Okay, so we can see here, hence the meaning of the name pH is justified as the power of hydrogen. That means pH stand for the power of hydrogen. That means if the power of hydrogen is high, then the acid will be stronger in nature. If the power of the hydrogen is less, so it will, we can say that the it will be a weaker acid. But how it is affecting the pH, we'll see that. Okay, so don't worry about it. Mathematical definition of pH is little less intuitive but more useful in general. It states that pH equals the negative logarithm value of the concentration of hydrogen ion. See, student, this equation is pH equals to minus logarithm of the H ion. Okay, now for now you are in class 7th, so you don't know how to solve the log. Okay, log, like how we are going to solve the log if you are having to find out pH. So don't worry about this thing. First of all, what you have to remember is, if someone asks you what is the pH, so pH you can define as the negative logarithm of the H ion. And what's the pH is? pH is power of hydrogen. As and like your teacher has told you already, that whenever there is the more H ions, so it will be a stronger acid, and when there will be the less H ion, then it will be a weak acid. And how it will affect the pH part, like how the pH is going to be affected by the hydrogen ion concentration, we'll see that. Just wait for it. You have to be patient because it's a new concept for you, so I don't want to rush in that. Okay, so we'll see this thing also. Just for now, see, student, what happened, like I'll just show you one example, but don't worry about it. Okay, example is that if the concentration of the H ion is given as the 10 raised power minus 2 molar. Okay, see, student, this is the concentration, or you can write down it as the 0.01. Exactly, we can write down it in this form, molar. See, student, this molar, that is the molar, represents the molarity. Molarity is the another name for the concentration. Okay, and these molarity sums, or how we calculate the molarity, you are going to find out in your higher classes. Okay, so don't worry about this thing. It's just that what you have to see is that that they have given you the concentration is this much. Okay, don't worry about it. Now if someone use the formula, that is pH is equals to minus logarithm of the H ion. Now concentration of the H ion is 0.01, and always remember this thing, student, that the concentration is always written in these type of brackets. Okay, you can't make them curly brackets, or you can't make them that curved brackets, so they all are this type of bracket. Actually right now I'm just forgetting, like parentheses are this or parentheses are this, so maybe parentheses are this one only. So just try to learn that what I'm trying to teach you. Okay, now the concentration is given you to you 0.01. Now as you don't know exactly how to solve the log, so students, what happened, that the solving of the log is the different method which you don't know right now. So it's just that after solving it, I'm telling you the directive, that is pH comes out to be 2. So don't worry about this thing. What happened, student, I'll just teach you the very basic thing. It is minus log and 10 raised power minus 2. Okay, it is the property of the log that whenever anything is in the power, so it just come outside like this. Okay, and it just remain as log 10, and the value of log 10 is already fixed, which is 1. Okay, it is fixed that the value of log 10 is 1, and after that we are just left with 2, and that's how the pH comes out to be 2. Okay, students, that's how we solve the pH of anything. But right now, as you don't know more about the log and the anti-log, so don't worry about this thing. It's just that we have to generally, what we have to study in this, that what is the pH scale, and what's the correct definition about the pH scale is that it's the negative logarithm of the H ion concentration. Now it's our duty that how we are going to find out that how the H ion concentration relates with the pH. If the H ion is more, so how the pH is going to be show its impact. So that's how we are going to find it out, both in the case of acid as well as in the case of bases. Okay, so I have just given you one very small example so that you will be understandable that how the formula has been used. Okay, so don't get very deep for logarithm of the anti-logarithm because they are the concept of higher classes. Okay, so don't worry. Now, see students, as you can see here that this is the litmus paper, and in this condition, like this is the first condition and this is the second condition. So in the first condition, student, what we have observed that this is the acidic solution, that is why blue litmus has been changed to red, that means this is the acidic solution. Exactly. And in the second condition what we can see that the red litmus has been converted into the blue, that means it is a basic condition. Okay, if it is acidic condition, so obviously it is having the H ions, and if it is the basic condition, so it is having the OH negative ions. Okay, so what happens, student, whenever there is the H ion and there is the OH negative ion, and if we mix both these together, so there will be the neutralization reaction and it will get converted into the H2O, and that is called as the neutralization reaction only. Okay, so that's how, student, if the change of the litmus color paper is changing from either color, like from blue to red or red to blue, depending upon that what type of solution is there, so we'll see that whether there is the H ion or the OH negative ion, and then how we come to know that okay, it is acidic in nature and this is basic in nature. And there is the another condition also, like basic acidic, when there is a neutral solution. Okay, that means it is neither having the H ions nor OH negative ion. These two are absent. Okay, so in that condition, what happened? Not exactly absent. That it's not like that they are not there. It's just that they are neutralized with each other. So in that condition, either if you use red litmus or if you use blue litmus color paper, so there will be no color change. No color change, and that's how you will come to know that whether the solution is neutral, acidic, or basic. Fine. So for example, student, if there are three test tube. Okay, I'm just drawing the test tube. Okay, and they are having some solution in them. Okay, these are the solutions. Fine, and it is A, it is B, and it is C. Now your teacher says that use the litmus paper. You have to use the red litmus paper. Fine. And see, student, what happened now? Like if you are using the red litmus paper, so in the case of the neutral and in the case of the acidic, it will remain red. So you will not find out the difference between the acidic and V. So that is why you have to use the blue as well. Okay, so now on basis of that, they ask you that please differentiate whether the A is acid or B is or matlab, you have to tell them that among these three which is acidic, which is basic, and which is neutral. So what you can do, you can one by one use the litmus paper, you can record it that which is showing the which type of color, and then use the blue litmus paper. If what happened, if B and C both are showing the red color with the red litmus paper, so in that condition what you can do is you can use the blue color litmus paper. If the C changes the blue to the red, so what we'll find out that the C is acidic and the B is neutral one, because in that B blue will remain blue. So that's how we can find out whether the solution is acidic in nature or basic in nature. And if it is acidic, so definitely it will having the H ions, and if it is blue, then it will having the OH negative ion. And if the litmus paper is not changing any color, so we'll find out that it is neutral. Now we are seeing how, like, why we are discussing it. Okay, now we come to know that okay, it is acidic, it is basic. Now if we have to find out what's the pH is, so students, the color of the litmus paper can help you to understand what is the pH. How? See, this is the pH scale, students, and you can see that they are having the different colors over here. Exactly, they are having different color. So the litmus paper which we are having, that litmus paper will also having some color. Exactly, it is having some color, and that color we can compare with these color. And if the color, For example, we are taking, okay, that we can say that the test tube A is acidic in nature. Okay, if it is acidic in nature, student, and if you are adding the blue litmus paper into it, so definitely it will convert into the red. Okay, and if that red color litmus paper matches with this red, so what you will find it out, that the pH of this test tube A, okay, that you can say that the solution, exactly the solution which is present in it. See, first of all, you don't know that it is acidic in nature, but when you have done the litmus paper test, then you'll come to know that okay, this is acidic in nature, and its color and the color is matching with this one. So that means the test tube A, the acid which is present in it, its pH is 1, because you're comparing it with the pH scale. Okay, so that's how, student, you can find it out whether the pH is whatever the pH of it by comparing the color of the litmus paper with the pH scale. Okay, now students, if you have observed here that the 7 pH range is neutral, that the pH scale starts from 1 to 14. Okay, now till now we have seen that okay, by comparing the color we can identify whether it is acidic or not, or whether it is basic or not. But now the again question comes here, that how we will determine whether it is a strong acid or a weak acid on the basis of pH. Fine, now we are going to see that thing. So look at it here very carefully. See, it is saying that from the after pH 7, the 8 to 18, 8 to 14 range, it is a range of the alkaline medium. Alkaline medium, student, means it is the range for the basic medium. That means 8 to 14 pH is a pH of the base, and 1 to 6 pH is a pH range of the acids. Okay, now if you observe here that it is the slightly alkaline, that means at that whenever if the pH of any base solution is 8, that means it is the weak base, because you can see slightly alkaline, that means it is less basic. So that's why what we can see, that if any of the basic solution is having the pH is equals to it, that means it would be a weak base. Okay, so I'm just writing the abbreviation here: weak base, weak acid, Sa, strong acid, and Sb is a strong base, because we can't write down again so lengthy words, so that's why I'm using some short form. So when there is the less basic solution, that means whenever the pH of the solution is 8, so we can say that it is a weak base. But if we move from left to right, so what will happen, that the basic character increases, that it, you can see here it is the very alkaline, that means it is more basic in nature. If it is more basic in nature, students, so what will happen, if any of the pH strip color matches with the 14, that means the pH of that basic solution is 14. That means, student, what you will say, that it is a strong base. Okay, so what we have seen in the case of the bases, that pH ranges from 8 to 14, and when if what we can see here, that if the pH is 8, that means it is a weak base, and when we move from pH 8 to pH 14, the basic character increases and we say it as the strong base. Okay, fine, that is clear to you. Now coming to the acid part, student. See, what's the acid part says? Acid part says that, you can see here, it is slightly acidic and it is very acidic. If it is slightly acidic, that means it is a, you can say it is more strong acid, and if it is, oh sorry, slightly acidic, that means it is a less acidic in nature. Okay, it is less acidic. That means if any of the acid is having the pH of 6, that means it will be a weak acid, and if any of the acid is having the pH 1, that it will be a strong acid. Okay, so it's just that what we have find it out here, student, that whenever the pH is 1 to 6 is the range for the acid, and if the pH is 1, then it will be a strong acid, And if we move from left to right, or from you can see from slightly to very acidic, so what we have observed, if that the pH is 6, then it will be a weak acid. Okay, so what we have seen till now, it's just that student, whenever we are having any solution and if you tested it with the help of the litmus paper, you can recheck or you can matches the color of the litmus paper with the pH scale, and the color matches with the pH scale. From that you will come to know, okay, that the particular solution is having this much pH. Now if the pH is coming below 7, that means it is acidic, and if the pH is coming greater than 7, that means it is basic. Exactly. And now if we compare between the acid and between base, that which is more stronger and which is weaker, so we have seen that 8, if the pH is 8, then it will be slightly basic, and that means it is a weak base. And if it is a strong base, and pH is more. But if we talk about acid, if it is a strong acid, then it will be that pH is more, but if the pH is less for the acid, then it will be a weak acid. Okay, I hope you got the point about this thing. Exactly. Now students, how the pH is affecting the H ion concentration or the for the basic part, so we have to see that thing also. So just give me a minute. Actually what I can do is I can use one more slide so that I can make you understand very well. Okay, so don't worry about it. Here we are, because I don't want you to make any confusion in your mind. Exactly. So just try to understand here. Like we are talking about pH scale. Exactly, student. So first of all, we talk about acids. Fine. So from the pH scale, what we have seen, student, that the pH scale ranges from 1 to 6 for the acid. Exactly, from 1 to 6. That means 1, 2, 3, 4, 5, 6. This is a range of the acid. And what we have seen, that whenever the pH is 6, then it will be least acidic. That means less acidic in nature. Fine. And if it is less acidic in nature, that means it will be a weak acid. And if it will be a weak acid, so obviously students, what will happen? It is having the less number of hydrogen ions. Okay. And if it is having the less number of hydrogen ion, that means its pH is more. Exactly. So what we can conclude from here, that if the H number ion decreases, or you can say concentration decreases, so H number of ion we can say directly, not the concentration. If the H ion decreases, so what will be the effect of pH? That the pH is going to be increased. Okay. This represent the decrease and this represent the increase. Fine. So if anyhow you are having two acid solution, and if one is having the pH 1, and for example if one is having the pH 2 and one is having the pH 5, so which will be more acidic? Obviously pH 2, because in the case of the pH 2, the more will be the H ions. Okay, so if it is the 2 or if it is 1, so in that condition, student, it will be more acidic. And if it will be the more acidic, student, so what will happen? Then it will be a strong acid. And for the strong acid, we have already seen this thing, that there will be the more number of H ions. And if there is the more number of H ions, then it will be a strong acid. Fine. So for example, if we are having two test tube, 1 and 2, and for the one test tube, the pH comes out to be 4, and for the two test tube, pH comes out to be 1. If someone asks you that which will be more acidic, because student, you can see that the pH range is obviously lesser than 6, well, lesser than 7. If it is lesser than 7, so obviously it is coming in the acidic range, but we have to tell that which one is more acidic. So you will observe that the pH 1 is for the strong acid. That is why the solution which is having pH 1, it will be strong acid, whereas the solution which is having pH 4, it will be weak acid. Okay. So that's how you can differentiate between the acids on the dependence of their pH. Fine. Now, second thing, what we can see about the base. Now, when there is a base, so it ranges from 8 to 14, because for 7 it is the neutral. Okay, like for distilled water, so we say it is the neutral one. So from 8 to 14, 8, 9, 10, 11, 12, 13, 14. That's the condition. And in the pH scale, we have seen this thing, when the 8 is there, it is less basic, and for 14 we have seen it is more basic. Okay, and see student, base like acid depends on H ion and the base depends upon the OH negative ions. Exactly. But students, what happened is that whenever there is a pH scale, so that is why student we see the pH for the basic solution as well. But you will say, ma'am, pH is the concentration, like it is the negative logarithm of the H ion, but in the condition of base we are not getting H ions. Exactly, because it is having the more number of OH negative ions. So how we are going to find out pH? So that is how student, if there is the pH which is negative logarithm of the H ion, so the POH is, that is the power of the hydroxyl ion, is equals to the minus logarithm of the OH negative ion. Okay, and that's how student, pH plus POH comes out to be 14. Fine. That is why student, whenever we have to calculate the pH for the basic part, so what we'll do, we use the formula that the POH is equals to the minus logarithm of the, or the negative logarithm of the OH ion, and from that you will get the POH, and that POH you can put up in this formula, and from there you will find out the pH of the basic solution. Because student, we are having the pH scale, in generally we can say that it could be also pH scale, but generally we talk as the pH scale. That is why we find out the pH for the acid as well and for the base as well. Okay, but it's just that the pOH is there. So see, whenever there is the more basic, so obviously it will be a strong base, and for the strong base there will be more number of OH ions. And whenever there is a OH ions is more, so what will happen student, that the that you can see that the POH increases. Exactly. And if the POH increases, so the pH is, so you can see, sorry, POH decreases. Fine. And when the POH decreases, so the pH increases. So for that, you can see that for the, if it is more basic, and it is the pH of it. So you can see here that whenever there is the OH ion increases, OH ion increases, so the pH also increases. You just have to remember this thing for now. Okay. Now, when if it is the pH is 8, that means it is less basic. And if it will be a weak base, that means it will having a less number of OH negative ions. And when there is a less number of OH negative ions, so obviously it will having the pH less. So that's a student, because pH is inversely proportional to POH. Okay, when the pH increases, POH decreases. So that's how you can remember this thing. But for now, if again, if someone is giving you two solution, and if it is basic in nature, and if you are getting the pH is 13 and pH is 9, so which will be more basic? So obviously 13 one will be more basic, because when there is the more OH negative ion, so the pH will be more. So for the acid, what you have to remember is that when the H ion is less, then the pH is more, but when the OH ions is more, so the pH will also be more. Okay, so that's the whole point of view of using the pH scale and determining whether what is the acid or what is the base, and how they are differentiating as strong acid, strong base, or the weak acid or weak base. Fine students, I hope you got the point about this thing, that how you are going to find it out from your pH scale. Exactly. As C student, we are having more thing about pH scale, but for now it will be very enough for you. That is why I don't want to make you confused. Okay, it's just that for 1 to 6 range is the acidic range, where the H ions will be there. For the 8 to 14 range, it is the basic range, where OH negative ions will be there. And when H ions will be less, then the pH increases, because we have seen this thing from the um, from where, that the pH scale. As you can see here, na, that the slightly acidic and very acidic. And if it is very acidic, that means it will be a more acidic in nature. Strong acid, more number of H ions. More number of H ions are there, that means the pH will be less. But in this case, for the base, as we have seen here, that the very alkaline is for 14, and if it is very alkaline, that means more basic, strong base, more number of OH ions, and if it is the more OH ions, then its pH increases. And how you can calculate the pOH? It's just that minus logarithm, and you can use this formula. If someone gives you that the pOH of the base solution is 10, what's its pH? So you can easily find it out, that 14 minus pOH, that is equals to 14 minus 10, that is the 4. That means its pH is 4. Okay, so that's how you can solve your question. Fine, students. Whether I have taken a very rough equation, whether the pOH is 10, it's like that it will come less, so that the pH will become higher for the basic part. Okay, so don't worry about it. It's just that I have given you the example that how can you use it. Okay, but it will be a same concept. What you have to remember, these 2 points. Fine. Now the pH part has been completed. Now we are moving towards the neutralization. Okay, so neutralization, you can see that the pH is equal to 7 for the neutralization. So exactly for the neutralization reaction, student, what we have seen, that when there is a combination of the H ions and the OH ion which has been generated into the water, and they get neutralized with each other, so there is the formation of salt along with the water, and that reaction is called as the neutralization reaction. As you can also see, it is HCl, NaOH, H2O and NaCl. That means when acid reacts with base, so there will be the formation of salt plus H2O. And how it is forming? See, if it is HCl and if it is the NaOH, so from here we are getting H ions, and from here we are getting OH ions, and that's how NaCl will combine together and we get H2O. And it is the neutralization reaction. And for neutralization reaction, student, when there is a reaction between the strong acid and strong base, see, just remember one thing, it's not always like that when acid and base are reacting together and its pH will be equals to 7. No, there is an important condition when there is a strong acid and a strong base. So such type of reaction, neutralization reaction, has like having the pH equals to 7. But if the condition changes, when if it is the strong acid and a weak base, or a strong base or a weak acid, then its pH is not equal to 7. Okay, but generally when we are having the strong acid and a strong base and they react together, there is a formation of salt along with water, and at that condition the pH is equal to 7. Okay, so just remember this thing, that pH is equal to 7 for that condition when there is a strong acid and a strong base. Now you'll say, ma'am, how we'll come to know? So definitely, student, from the pH only. HCl is a kind of a mineral acid which are obviously stronger one. If I tell you acetic acid, so you'll say, ma'am, it's the organic one, so obviously it is a weak acid. So that's how we can see with the strong acid is there or strong base, and they react with each other and then neutralized, and we get the salt and water. Fine. Now see, student, this neutralization reaction is very important in our daily life as well. So how we are looking at the neutralization in our daily life? So we are going to find out that thing. Okay. Okay. So first of all, it is the indigestion process. See, whenever if I say you eat more food, or it's like you have gone to some wedding, and at that in that wedding you have eat more because the food was very tasty, but due to that condition you are feeling some like you are feeling that acidity has increased in your stomach or something like that. So what happens, student? You feel very discomfort, and when that is the problem, so that means there is the acidity has been increased in your stomach. Okay, acidity increases, and when that acidity increases inside your stomach, because student, in your stomach there is the HCl which is used for the digestion purpose, and if that acidic level increases, so to neutralize that acid we use the antacids. and those antacids are what? Base in nature. And when that base react with the acid, so what will happen? There is a neutralization reaction, and when there is a neutralization reaction, then you will feel relief. So that's how the indigestion, like you will see the neutralization reaction in the case of indigestion. So indigestion, also called as dyspepsia or an upset stomach, in a general term that describes discomfort in your upper abdomen, exactly in your stomach. Indigestion is not a kind of disease, but you can say whenever you have eat, like eat something, or you like which is not good for eat at that time, so that's how the acidity level increases in your stomach. And to neutralize that acid, we use antacids that are base in nature, and that's how the neutralization has go. Like milk of magnesia is basic in nature, which we generally use for the indigestion purpose, so that the acidity level will decrease, and there is the neutralization and we'll get the relief you experience, including abdominal pain and a feeling of fullness soon after you start eating. So that's how student, the acidity level increases, or you can see that the proper digestion is not going on. So that's how the neutralization helps here, that you can use the base part and then neutralization will be there and you will feel relief at that point. Okay, so this is the one thing. Now the second thing is the ant bite. See, the sting of an ant contains formic acid. If it is containing the formic acid, that means what happened? That ant is binding over your hand. That means she is injecting that acidic liquid inside your skin. And from that point, you start feeling itchiness or something like that. So what you can do is you can neutralize it by rubbing moist baking soda, that is sodium hydrogen carbonate, that is sodium hydrogen carbonate. This is the formula of the sodium hydrogen carbonate, or calamine solution, which contains zinc carbonate. That means it should be basic in nature. Okay, that means it is basic in nature. And from that, what will happen? There is the neutralization reaction will take place and you feel relief. That is a student, that the ant bite is formic in formic acid, but one of the ant is also there. If I don't like, if I am not getting that which is that, but it's like that, some ant is also which inject the basic part inside the skin, and you feel itchiness even though at that point also. So what you can do is you can use the vinegar and you can rub that vinegar over your that part, and that's how you get the relief. Because it's not like that only acid is there and you are adding the base. If the base is there and you are adding the acid, then also it will be a neutralization reaction. Okay, so that's how, if there is the indigestion, if there is the ant bite, so you can use the neutralization process in your daily life as well. Because acid is there, what you just have to do is you have to acid you just have to add the acid so that there will be neutralization. Okay, now the third part is soil treatment. See students, what happened now? Like if we are using more insecticide, oh sorry, we pesticides and something like that. So what happened, that the soil will become acidic in nature, and if that soil is becoming very acidic in nature, so we can't grow the crops over that. Like we are not that is not good for for growing crops, or you can say that it is not for that fertile in nature. So what we'll do, that whenever there is the acidic salt, so we just lime it. That means liming is done. Liming means that we neutralize this acid with the lime, that is the calcium oxide, and it is also base in nature. And again, when acid react with base, so there is the neutralization take place, and again the soil will get fine, and you can use that soil for the growth of the plant. Okay, so that's how student, neutralization of soil is sometimes necessary in order to promote the plant growth. If the acidic soil is there, cause soil to become acidic, some plants benefit from liming the soil. And same thing will be there if the basic part is more in your soil. So what you can do is you can add this acidic part, and then that's how you can do the soil treatment. These all are very simple. Exactly, what you just have to do is, the whether the basic is more or whether the acidic is more, you just have to add vice versa of it. Exactly, and that's how you'll get the neutralization, and you can use that thing easily. So we have seen indigestion, we have seen ant bite and soil treatment. Now, the fourth one is the factory wastes. So, factory wastes contain acid which, if untreated and discharged directly into the water bodies, so what will happen, student? That in the water, the acidic character or the acidic part will get increased, and if it is getting increased, so it is affecting the water life. Water life means the animals which live in water. So, what happened that that acid will affect their life. So that's how the aquatic organism or the fishes which are present on those water bodies are getting harmed because of that. Therefore, they should first be treated with basic substances to neutralize them and then discharge into the water bodies. But it's like that, student, I think so wastage should not be discharged. But if any worst condition is there and you are discharging your waste into the water bodies, what you have to do is, first of all, the waste which is acidic in nature, first of all neutralize it with some base and then discharge into the water bodies, so that the animals or the plants which are living in the water, their life will not get harm from that. Exactly. So that's a student, neutralization is used up in our daily life. There will be more example as well. For example, if you tell that the buccal cavity, okay, in our mouth, so what happened that some of the students or not only about students or children's I'm talking about, like generally some people got cavity in their mouth. So why, like what's the reason behind it? Because, student, what happened that the buccal cavity is having some acidic part, so that they can, like, the digestion process starts from the mouth only, so that the food gets start converting into the smaller parts or something like that. So what happened that whenever we eat more of the sugar, like chocolates or toffees or something like that, so that sugar convert into the acid. Okay, obviously our pH is like, you can say, if I talk about the buccal cavity or the cavity part, so in that part the pH is already 5.5. That means it is acidic in nature. Exactly. When it is acidic in nature, students, so what we'll do, like if you are eating more chocolates and more sugary things, so what happened, that sugar inside your buccal cavity will break down, convert into the acidic one with the help of the enzymes which are present in our buccal cavity. It is already acid, and if we are converting the sugar into the acid one by eating more and more chocolate, so you will see that the acidic part will get increased inside your buccal cavity. If that acidic part is increasing, so that will cause the cavity in your mouth. That is why, student, your parents doesn't allow you to eat more number of chocolates. But what you can do is, you can use, like, I know this thing and you have to do this thing also, like, and I can assure that you all do this thing uh, at daily basis, that always brush your teeth timely. Because what happened that the toothpaste which we are using, that toothpaste contains some base part, and that base part will neutralize the extra amount of the acid which is formed inside our mouth due to the consumption of chocolates and toffees, and that's how it get neutralized and we don't have any type of cavities. So that is why you are always, or not only you, all of us are advised to do the toothpaste two times, like once in the morning and in the night before going to your bed, so that whatever you have eaten in your daily, like in your whole day, so that you will just paste it and the acidic part will get removed and you will be not having any cavity problem. So that's a student, you can see that the neutralization is what it is doing, that it is indirectly maintaining the pH level. Okay, so what you can remember is, whenever, see, if something is there, so it will having some pH, okay, and that pH has to be maintained. But how it is going to be disbalanced, that acidic part may be increased or basic part may be increased. So to neutralize that extra amount, the neutralization reaction is required. That means, student, we have to maintain the pH level, as we have seen in the cavity part, like buccal cavity, that the pH is 5.5. So that toothpaste base will neutralize the extra acidic part, so that the pH will get maintained and the neutralization reaction will take place and you will not get any problem. So that's how the neutralization is important in our daily life, so that the pH will be maintained. See, everything is having their own pH which has to be maintained, and it has been fixed by God. Exactly, because inside our mouth it's 5.5, we haven't do anything for that, it's just that it's already the thing. Okay, it's around 5.5, I can say. So that's how we have to maintain it. If the pH is changing, so you will be facing problem, and if the pH is changing, definitely acidic or basic part is changing. So to neutralize that thing, we need more amount of base or more amount of acid depending upon the condition, and that's how the neutralization take place, and that's how the pH is maintained. And this pH maintenance and the neutralization is very important in our daily life, as we have seen many examples also. So that's the pH calculation, and that's how the pH is important for the that, or you can say that the neutralization is important for the pH maintenance in many ways. Fine. Okay, so we are having some questions. An antacid tablet is taken when you suffer from acidity. As we have already seen that thing in the indigestion part, that whenever the acidity part increases, so we have to take the antacid, so the neutralization will take place. Calmanine solution is applied on the skin when an ant bites, because what ant bites do, that it will inject the liquid, and that liquid is acidic in nature. So to get relief from it, we use the calamine solution because it is basic in nature. Factory waste is neutralized before disposing it into the water bodies. Exactly, because it is acidic in nature. So first of all, we have to combine it with base so that it will get neutralized and it will not harm the water bodies. Okay, so we are having answers already, or otherwise you can read it here, that the antacid tablet contains base like milk of magnesia, as I told you, which neutralizes the acid reduced in stomach, and that's how you will you will get relief from the acidity. And by it injects formic acid, and calamine consists zinc carbonate, which is basic in nature, so it will neutralize and you will get relief from it. Factory waste are acidic in nature, which may cause harm to aquatic life, and hence they are neutralized by using a base. So that's how we can do it. So see, student, whether any condition is there, whether base part is more, acid part is more, you just have to add the like base or acid, whether the neutralization is done, so that the pH will be maintained. Okay. Oh, so we have completed this chapter, students. We have learned about acid, bases, salt, pH, and how pH is affecting with H ions, with OH ion, and how the neutralization is working in daily life, and how it is maintaining the pH level. So we have completed this chapter, acid, bases, and salts. And now it's your duty to learn each and everything with very great attention. Watch all of the videos of the chapter with great attention, because I have already told you it is a very important chapter for your further from the prospect, like if we say from the perspective of your future uh, syllabus also, which you are going to study in your higher classes. So just try to remember each and everything, practice more, even though you can see some of the question as well from this chapter, because this chapter contains logical part. So see, every chapter has a logical part, but it's just that in some of the chapter we have to learn things, but in some of the chapter we have to apply the logics as well. So that's how you can see, you can do very well in this chapter. But it's just that if you have any question, any query, you can post your question over the public forum or the private forum of the Ask IITians, and you will get your answer from the expert side. And that's how your chapter will be done for you. From my side, I have done it. Now it's your turn. So just learn it very carefully, watch the session carefully, and in the last, thank you very much for attending the session.